The move that we just made to be able to easily divide decimals could also be made the other way around to make certain types of whole number division easier. Let's suppose, for example, that we wanted to divide 835 by 40. These are both whole numbers. There's no obvious relationship to whole number division. These are both whole numbers. There's no obvious relationship to decimal division. But notice that here I'm dividing by 40, and it would be much more convenient to divide by 4. It turns out we can make the same move that we made to divide by decimals to divide by a smaller whole number in this case. In particular, we'd like to be able to move the decimal point one place to the left in the divisor. And we can do that as long as we do the same thing in the dividend. What's going on here? In fraction notation, we have that in fraction notation, what we're saying here is 835 wholes divided by 40 wholes, which we can write as 835 wholes times 1/40, taking the reciprocal. But 40, right, this denominator here, 40 has 10 as a factor. If I write 40 as 4 times 10, then I can think of this as 835 tenths times 1/4. That is 835 tenths divided by 4 wholes, or 83.5 divided by 4. Practical upshot: if the divisor has trailing zeros, we can move the decimal point to the left to make the division easier. So our original problem again was 835 divided by 40, and we think that we can rewrite that as 83.5 divided by 4. Now there's nothing wrong with this division problem. We can do it. It's just harder than it needs to be. 4 goes into 8, not at all. It goes into 83 twice. 2 times 4 is 8, so 2 times 40 is 80. Subtract, I get 3. Bring down the 5. 40 goes into 35, not at all. And so I bring in another 0, since there's something left over. 40 goes into 350, 8 times. 8 times 4 is 32, so 8 times 40 is 320. Subtract. And now I'll need another 0. 40 goes into 300 7 times. 7 times 4 is 28, so 7 times 40 is 280. Subtract, I have 20 left. One more 0. Bring it down. 40 goes into 200 5 times. 5 times 4 is 20, so 5 times 40 is 200. Alright, not that bad. Nothing wrong with it. Let's see how this goes if we think of it as dividing by 4. 4 goes into 8 twice. 2 times 4 is 8. Subtract and get 0. Bring down the 3. 4 goes into 3, not at all. 0 times 4 is 0. Subtract, I have 3. Bring down the 5. 4 goes into 35 8 times, since 8 times 4 is 32. 3 left. Write in another 0. 4 goes into 37 times, since 7 times 4 is 28. 30 minus 28 is 2. Bring in one more 0. 4 goes into 25 times. 5 times 4 is 20. Nothing left over. As you can see, we get the same answer. And we really do about the same steps. What's the difference? The difference is we do a little bit less writing over here. Now this would have been a lot more work if we had written out every time that we multiplied by 40, if we hadn't taken advantage of this trailing 0 in the multiplication. I'm going to give you one of these to try, and though I don't demand that you use this trick every time, I do want you to practice it in this one example. Divide 862.2 by 300, taking advantage of the trailing zeros. Give your answer as a decimal or a repeating decimal. Pause the video and try this now. Alright, so we want to get rid of those trailing zeros in the divisor. To get rid of the trailing zeros, we need to move our decimal point 2 places to the left. That is, divide the divisor by 100. We should do the same in the dividend. We'll have 8.622. So the division problem we'll actually work out is 8.622 divided by 3. We'll write that down. 3 into 8.622. 3 goes into 8 twice. 2 times 3 is 6. 2 remains. Bring down the 6. 3 goes into 26 8 times, because 8 times 3 is 24. 6 minus 4 is 2. 2 minus 2 is 0. Bring down the 2. 3 goes into 22 7 times, since 7 times 3 is 21. 2 minus 2 is 1. 2 minus 1 is 1. 2 minus 2 is 0. Bring down the 2. 3 goes into 12 4 times. 4 times 3 is 12, and so nothing remains. So, the answer to my original division problem should be 862.2 divided by 300 is 2.874.